Hello everyone. Today we are looking at prime factorization and exponents lesson 6, and with a focus on scientific notation. So we did look a little bit at scientific notation in our grade 9 review package, and you might have covered it in grade 9, or you should have covered it in grade 9, but not all of you did. And so now we're going to do a quick lesson on it here. Hopefully this either shakes off the rest or allows you to learn a new skill. So let's begin. Scientific notation, looking at large numbers. So oftentimes in science, we end up using really big numbers or really small numbers, and it's a bit of a pain to write them normally. For example, right here, we have a 2016 census shows that Canada has over 260,000 First Peoples language speakers. Or another example is the distance from Earth to the Sun is approximately 93 million miles. And the number of molecules of gas per meter cubed is approximately 27 with a lot of zeros. I don't even know what that is. We should probably Google that at some point. So you can see that they are hard to deal with when they're written like that. If you had to write this number 5 or 6 times, it's going to be a pain in the butt. And that's where scientific notation comes in. It's a really nice way to write too large or too small of numbers. So the example that they use right here is that we have 32,000. So I'm going to kind of explain it over here. 32,000 is a large number, right? 32,000 can be also written as 32 multiplied by 1,000, because there's 32 thousands, or even smaller, 3.2 multiplied by 10,000. The reason we want to put it into a base 10, like 1,000, 100, 10,000, 100,000, is because now we can convert this 10,000 into 3.2 multiplied by 10 to the power of 1, 2, 3. There's 4 zeros. 10 to the power of 4. And that is scientific notation. It allows you to write that 32,000 as a small number here, to the multiplied by 10 to the power of something. And it makes everything a lot easier. So what I'm going to do is kind of teach you an easier way to do this rather than using the expanded form. I will fill that in, but I'll show you a quick and easy way to do this that makes a little bit more sense, I think. So the expanded form of 61,500 is 6.15, and then we are going to go multiplied by 10, multiplied by 10, multiplied by 10, 4 times, multiplied by 10. And we get 6.15 multiplied by 10 to the power of 4. The easier way to think about this is start by figuring out where the decimal place is. The decimal place is right behind that 0. And we're going to move that decimal place. We always want the decimal place right here behind the first digit. So to get there, we have to jump 1, 2, 3, 4 spaces. I apologize if that scribbling is a little bit tough to follow. 65,000. So we're taking that decimal place and we're going 1 jump, 2 jumps, 3 jumps, 4 jumps, so that we can place it right there. So we're doing 4 jumps to the right, which means we're going to have 61,000. Oh man, I totally messed that up. I apologize. Let's start over really quick. 61,500. So we're going to do our jump. 1, 2, 3, 4. Still 4 jumps. We're doing 4 to the left. So we can rewrite that as 6.15 multiplied by 10. And then we did 4 jumps to the left, so it's to the power of 4. 6.5 times 10 to the power of 4. So let's skip this expanded form and let's do the same thing with 500,000. So we want to write that as 5 or 5.00, however you want to write it. 5 would work just fine. And we're going to move that decimal place 1, 2, 3, 4, 5 spots to the left, which means we're going to go multiplied by 10 to the power of 5. With 46.3, we just want to, the decimal place is already in the number, so we just want to move it 1 to the left, which means we're going to be 4.63 multiplied by 10 to the power of 1. So it's kind of silly to do it with this small of a number, but when you've got, you know, bigger numbers, 10 to the power of 5, 10 to the power of 4, it does get easier to do it. Here they've given us 2.81 multiplied by 10 multiplied by 10. So it's 2.81 multiplied by 10 to the 2. So now we have scientific notation and we want to go back to standard notation. So the best way to do that is you go 2.81. I don't know why my numbers are getting mixed up today. 2.81, and it's 10 to the 2. So it's a positive exponent, meaning that this number is going to be a larger number. So we're going to go 2 jumps backwards and put our decimal place behind. So that should be 281. 281. Another way you can think about it is you can just say, well, it's 2.81 multiplied by 10 to the 2. 2.81. 10 to the 2 is 10 times 10, which is 100. And then just multiply those together and you get 281. I like moving the decimal place. I think it's just pretty quick. For example, here I have 9.2. And it's going to be times 10 to the 2, so it's getting bigger. It's positive exponent. So I'm going to go 1 jump, 2 jumps. There's nothing here, so I can put a 0, and that becomes 920. The one above it, I just didn't realize I skipped it, is 7 multiplied by 10 to the power of 1, 2, 3, 4, 5. So if I have 7 to the power of 5, let's erase that here. That means my decimal place is sitting right after the 7, and I'm going to move it 5 times. 1, 2, 3, 4, 5. And every spot there has to be filled with a 0, or 5 zeros. So that means that is 700,000. Just like 5 times 10 to the 5 was 500,000, 7 times 10 to the 5 is 700,000. So let's take 1.4 times 10 to the 6, and we will put it in standard notation. So 1.4, and now we want to move that decimal 6 times. 1, 2, 3, 4, 5, 6. I'm going to add zeros into all of those little places, and it looks like we have 1,400,000. Perfect. So that's dealing with really large numbers. So we're going to do some examples. I'm going to skip over this and just look at some examples here. So here it says, convert the following numbers from scientific notation to standard notation. So what we want to do is take our 3.8, and it's getting bigger. It's a big number. 10 to the 7 is a positive exponent. It's a large number. So to make 3.8 bigger, we have to move the decimal place to the right 7 times. 1, 2, 3, 4, 5, 6, 7. So add zeros in there. And that means our final answer is going to be 38 million. I'll do C here. So same thing, 2.9. And it's a positive exponent, so it's a bigger number. So we're going to move our decimal place 3 times to make this number bigger. 1, 2, 3. We're going to place it there. And it looks like we get 2,900. We can start adding in some scientific or some exponent rules or exponent laws here if we want. So now we have 7.1 times 10 to the 2, all multiplied by 1,000. The easiest way to do this is to keep that 7.1 for now. And we're going to multiply by 10 to the 2. And we're going to write 1,000 as 10 to the 3. So anytime you have, 10, 100, 1,000, 10,000, any multiple of 10, you can rewrite those as powers of 10, and you count the zeros. So 10 has 1 0. It's going to be 10 to the power of 1. 100 has 2 zeros. So it's going to be 10 to the power of 2. And so on and so forth. 1,000 has 3 zeros, 10 to the power of 3. So we're going to write 1,000 as 10 to the power of 3. We can deal with these two terms together because they're powers with the same base. We multiply powers with the same base. We add them. So this should be equal to 7.1 multiplied by 10 to the power of 5. And the answer wanted us to keep it in scientific notation, so that is our final answer right there. I'm not going to do B, but if you were to do B, just be careful because this is 10 to the power of 1. So they like to fool you with that. You don't have to write exponent 1, but it's there. So you would do the same thing we did in A, but with adding 7 and 1. Let's look at C. C is 5 times 10 to the 6 divided by 1,000. What we can do is say 5 times 10 to the 6, and then we can write that 1,000 as an exponent divided by 10 to the 3. And you guys remember that when we divide exponents with the same base, we subtract the exponents. So now this turns into 5 multiplied by 10 to the power of 6 minus 3 is 3. And that's our final answer. Again, we're leaving that in scientific notation. So that is scientific notation of big numbers. Now we're going to look at scientific notation of small numbers. I'm just going to scroll up here. So really, really small numbers, again, a pain in the butt to deal with. So what we want to do is write them in scientific notation so that they are easier to deal with, easier to write. If we're doing any science experiments and we're doing any lab write-ups, it would be a pain to write, this number several times in a lab write-up. But if we can write that as in scientific notation, it makes everything a lot easier. By the way, that is such a small mass. That's the mass of an electron in grams. That is tiny. So it's actually it's the exact same as scientific notation with large numbers, but instead of using positive exponents, we're using negative exponents. So if we look at the first one, 0.00053, we're going to count. We know that we want scientific notation to start with 5.3. The decimal always comes right behind the first digit. But how do we get the decimal place there? We got to count our jumps here. 1, 2, 3, 4 jumps. So multiplied by 10, not to the positive 4 this time, because it's a small number. It's a really, really small number. So times 10 to the negative 4. So it's going to be a negative exponent if it's a really small number. Same with the next one. We have 0.0000007. So we want that to be 7. We want the decimal place behind the first digit. In this case, it's the only non-zero digit, so we'll just leave it as 7 multiplied by 10. And now we've got to figure out what that exponent is. So we want to count our jumps here. 1, 2, 3, 4, 5, 6, 7, 8. So it'll be 7 times 10 to the negative 8. we can use the expanded form. So when we looked at expanded form of big numbers, it was 2.9 multiplied by a bunch of factors of 10. This time we're looking at 2.9 divided by a bunch of factors of 10. If you remember from our previous lessons that a negative exponent is basically an exponent on the bottom. So this also could be, or an unhappy exponent, sorry. So you want to switch it from top to bottom. So this 7 times 10 to the negative 8 can also be thought of as 7 divided by 10 to the positive 8. That's the exact same thing, but that's besides the point here. So we can rewrite this as 2.9 multiplied by 10 to the negative 3. So scientific notation is really the only time that we use negative exponents. Any other time you would switch it to the positive exponent, but with scientific notation, it's totally okay to use the negative exponent. So in this case, we have 2.9 multiplied by 10 to the negative 3. So now if I wanted to write that in standard notation, I would say, okay, I have 2.9. It's to the power of negative 3 times 10 to the power of negative 3. So it's a negative exponent, which means it's a very small number. So if I start taking my decimal place, I'm like, I need to make it 3 jumps. So if you go 1, 2, 3, yay, I have the standard notation is 29,000. Stop and think about that for a second. It's a negative exponent, so it should be a really small number, or smaller than the 2.9. Is 29,000 smaller than 2.9 or lesser? It's not. So maybe take a second and go, wait, maybe I was supposed to jump this decimal place the other way. 1, 2, 3, and have 0.0029. 0.0029. So this is all wrong. It should be a smaller number than what you begin with. So let's do 7.1 multiplied by 10 to the power of negative 1, 2, 3, 4, 5, 6. And now what you can do is, okay, well, we want to write that in standard notation. So I have 7.1, and I want to do 6 jumps to make this number smaller, or 6 jumps to the left. 1, 2, 3, 4, 5, 6. And now we can write that as 0, I'm in the wrong column here, wrong row, 0.1, 2, 3, 4, 5, 7, 1. So we don't have to do this step right here. We can take scientific notation and put it back into standard notation. You start with your 3.1 and you make your jumps. It's a negative 3. It's going to be a smaller number. 1, 2, 3, 0.0031. 0.0031. 8.5. We're going to do 5 jumps to make it smaller. 1, 2, 3, 4, 5. So that number is 0.000085. So that's scientific notation of a small number, or negative exponents. Okay, so the next question is, explain why 0.4 times 10 to the negative 8 is not written in scientific notation. It looks like it is, but you have to be careful here because it is 0.4, and we always want the decimal to be behind the digit. 4.0 or just 4 times 10. So now it was 4 times 10 to the negative 8, or 0.4 times 10 to the negative 8. We had to jump that exponent one more. So we had to go towards the right. So it should be 0.4. Oh wait, it tells us right here, right? 0.4 times 10 to the negative 8 in scientific notation. So let's just focus on this. 0.4 we want to write as 4, and then this is a smaller number than 4. So this should be multiplied by 10 to a negative exponent. we had to do one jump with our decimal, so it should be to the power of -1. But we still have that times 10 to the -8. So now that we've done that, we want to combine those. So it'll be 4 multiplied by 10. We're multiplying powers with the same base, so we're adding the exponents. -1 plus -8. You owe $1, now you owe 8 more dollars, so you owe $9. 4 times 10 to the -9. Scientific notation in a calculator. So each calculator is a little bit different. So this is just one calculator. I don't think anybody has these calculators anymore. These are the TI graphing calculators. So what we will do for scientific notation in calculators is I will look at yours individually and we will figure it out. You can always say like 3 and then go multiplied by 10 to the power of 4. And that little hat button is your exponent. There are quicker ways to do it, but each calculator is a little bit different, so we'll go over them together in class. Cool.